Hey everyone, welcome to another video. In this video today, I'm going to be talking about how to set up a personal cloud with recursive DNS with an option to have a rotating Tor proxy. So the reason that I've been investigating this is sometimes on engagements, I might want to spin up a VPS on the cloud, connect my machine through the WireGuard straight into the server, and then my WireGuard configuration automatically has DNS settings set up, so it can automatically send my DNS request to a pihole that's on there. There's got Unbound already pre-configured, so all of my DNS requests are being funneled through there. So it's basically minimizing the chance that it can be traced back to me. However, this can be a fun learning exercise for anyone because setting up Pi-hole and Unbound is quite cool. And it's the same thing with the rotating Tor proxy. The way that we're going to have it set up is first we're going to focus on the WireGuard setup. We're going to get it so it can set up its own subnet on 1072.1.1. And then once we got WireGuard set up and ready to go, we're then going to install Pi-hole and Unbound. And then we're going to configure those two to only listen on the WireGuard subnet. Now, this is interesting because by default, Pi-hole only allows you to come from private DNSs. However, I only want it to listen on WireGuard. I don't want it to listen on all listeners because I don't want to expose that port to the internet. So in threat hunting, let's say my IP address gets found out in a red team exercise. What they're going to do first is they're going to try and scan my machine, and the only port they will find open is 22, which is SSH, which is quite common on most Linux boxes. The reason that I'm adding in the rotating Tor proxy as well is sometimes it's quite useful to, let's say, spin up GoBuster or any other tool that you just need to create a lot of noise. Send all your requests through Tor, create a lot of noise, burn out the SOC team that you're trying to waste their time on. However, there's one caveat to that. Obviously, we're relying on Tor. Most businesses, if they don't have any reason to trust anything from coming from Tor, they should just block it in general. If they haven't, obviously that leaves them to exposure to this type of attack. So I'm just going to get set up and I'll see you in 1 minute. But before we head on into the video, I would like to say thank you for everyone for your support on the Cloudflare video. We're around 3k views at the moment, so absolutely crazy. It was the first video that I've made. It was a little bit long. It's about 20 minutes. So I love everyone who went through to the very end. Everyone who's been leaving really nice comments on that video. You're the ones that keep me going on this adventure through cybersecurity and getting through to this. So all I ask is, could you like, comment, and subscribe on this video? I would love to know if you're going to have a go at this. It's a really cool exercise, and it also gets you involved in some of the tech that you can use in your red teaming exercises to evade detection. Welcome to the Ubuntu box. So firstly, on here, I would recommend for you to run apt update and then run apt upgrade -y, just because you want to make sure that it's on the latest version of everything. Before this, recording this video, I've already done that anyways. So the first thing we're going to do is we're going to install the WireGuard server. So on Ubuntu, it is apt install WireGuard and then -y, because I just wanted to go through and install. However, if you're on an RPM image, such as like Rocky, CentOS, those types of distributions, it is WireGuard-utils, I believe. Hey, I just wanted to quickly jump in and give some more context. It is not WireGuard-utils, it's WireGuard-tools on DNF distributions, or well, RPM distributions, just to let you know. Now we can get back to recorded Lawrence instead. For those ones, so just make sure that you tailor it to your box. Okay, once WireGuard is installed, we will head over to the etc WireGuard directory, and as you can see, there is no configuration out of the box. WireGuard is just a protocol that needs to be set up. So the first thing that we're going to do is we're going to generate the public and private key of the server. So make sure that you keep the private key always secure. For this, I'm going to be showing it. Obviously, this is going to be thrown away after this exercise. I'm not going to be using it. Like I said, I just spin them up and down whenever I need them. So the first thing that we're going to do is we're going to run umask, and I'll just paste the command in. So it's just umask 077, and then we're going to gen with the wg command, gen the key that into the private key, and then we'll do wg pub key, and then pipe that to the public key. Running that, we will end up with two files, the private key and the public key. So we need to make sure that we keep hold of these for now. Then I'm going to create the WG. So if we nano to create the wg0.conf, normally this is what I like to call the interface WG0. It's just easier to remember it that way, like WireGuard 0. Okay. Once this is done, I am going to paste in. Okay, so here's the pre-configured one that I have. So I'm just going to remove this, and then we're going to change it to 1072.1.1. I just rather have it in the 10's private IPs. Listening port 51820, that is WireGuard's default port. However, change this to your liking, to any other private port. And then obviously we need to get the private key of the server here. So first I'm going to save it to conf. Then I'm going to cap the private key. We're just going to grab the private key, go back into WG0, and we're going to replace this with the private key copied. Okay, so that is the basically setting up the server. It's that quick and simple. It's just a public private key. At the moment, it's just we don't have any clients yet connect, so we've just obviously just set up the server. So the way that we will do this now is I always like it so systemctl always handles the status of the interface. So we're just going to create a systemctl file. So the way that we can do that is if we do systemctl enable wg-quick at wg0. So wg-quick is just a script file that allows you to spin up and down interfaces really quickly. This wg0 is the name of the conf file. So if you've renamed it to anything other than wg0, you'll make sure that you make the changes here. So that will create a service file with the wg command. And then what we can do to make sure that our configuration is in fact correct is if we start the wg quick at wg0 service. And then we can see if it's running by just running the status command. So as you can see here, it's already running. So I just realized there's one step that I did miss, which we'll have to rectify now. So for your server to act as a forwarding server, you'll need to change a CTL configuration. So if we nano etc sysctl.conf, you'll see here that there should be a section here about net IPv4 forward equals 1. Depending on your system, I've noticed with some of the RPM based images, you don't get anything here. However, if you just copy this format, so net IPv4.IP_forward equals 1, that will then allow you to then forward that. If you do, however, have IPv6, you'll have to comment out the IPv6 version of that, which should also be in that file. To make those changes, we'll have to do sysctl -p. Make those changes on the fly without having to reboot the box. You'll see here that it's noticed the change and it's made the change for us. So now, since we've got the main server component set up, we'll now need to change over to the client. So on my machine here, I've already got an empty Wireguard directory, and I am now going to set it up to connect out to that box. Yes, sorry about that. So it is DNF list Wireguard -tools. So if you're on RPM, it is Wireguard -tools, not utils. Sorry about that at the start. I'll have to edit in a little pop-up on that. But yeah, on my Fedora image, I've already got the tools. So that's why I'm not installing it on the client here now. So we are going to be running the exact same umass command. So umass 077, we're going to gen a public key and a private key again. So we're just going to gen that. And now we've got a public key, private key again. From here, we are then going to create I like to call it burn.conf, because I know anything that was got burn configuration, that's just like a server that I just spin up temporarily, just for now, just to get some data on there. Okay, and then I'm going to then copy over the interface records again. So if I just vim now into the burn.conf, I paste, you'll see here now that I've got address. So let's say if I do 1072.1.2/. So this address will be the one step up from the one that you've configured. So if I go back to the server for a second, and if I less the wg.conf, you'll see down here that I set this address to be 1072.1.1. It's just the same thing with any subnets. You need to make sure that your IP addresses are unique per machine. So I've just picked the next one up, which is 1.2. And same thing again. We'll need to go get the private key. Get the private key. Go back into the burn.conf. And we're going to put the private key. Now, since we've got the client and also the server setup, we'll need to we need to now pass the public keys of the server and also the client to one another, because that's how the encryption works. Is that they both have each other's public keys, and then they just encrypt it with the private and then send it across. Yep. So if we if now we cap the public key, this is the public key of the client. We'll head over to the server first, and we'll update this configuration to have a peer dependency. So I'm going to just copy this that I've got written down, paste it in here, and then I'm going to update the IP. Okay, so the way that it works is that you put peer in brackets, and then we'll need to go get the public key. Is this here? And then there's the allowed IPs, there's the persistent. So this persistent keep alive means that every 25 seconds they'll send a signal to and from. Because Wireguard is UDP, there is no state. So it either works or it doesn't. There's no like handshake with like other VPNs. Because it's UDP, there is no state. So that is fine on a peer side here. So we're just going to right quit that. And then on the client side, we're now going to have to tell the peer about the server, which is the kind of the same deal. So we're going to copy that, paste the peer in here, and then we're going to type in the public IP address, which is, in my case, it's 178.62.101-245. And this is setting it up for a client dependency. So you make sure the endpoint is your server. If you've changed your port, you'll change it here. So I haven't, so mine's 51820. And this allowed IPs, I want to forward all my traffic. So 000/0 is forward everything to the server. But I need to go get the public key now. So if I cat the public key, here. So we've got the public key, everything is set up. So if we now do a systemctl restart on the server side, and that seems to work. So if we go and status, you now see that it's completely worked fine. There is no error in our configuration. And then on the client side, we're then going to run wg quick, and then we're going to say up, and then we're going to say burn. So this is exactly the same way of think of it the same way with the at command. However, wg-quick, and then you want to bring up, and then you give the file name, and that's just burn.conf. Okay. So we've got burn.conf. There was no errors that popped up there. So if I ping 1072.1.1, we now see that we're getting a reply. So now we have created a connection from our server, our client, sorry, to the server. So now it's time to get Pi-hole and Unbound installed. However, because now I've connected and forwarded all my traffic through the Wireguard server, I've now lost connection to the remote host. So now I need to reconnect. However, there's a fun detail that I would like to show you. Now, since I'm connecting and I've already got my tunnel set up, I don't need to now go to the remote, the WAN IP address. I can actually connect through the tunnel. So if I just type in my host, and then instead of connecting to the 172 address that I had for the remote WAN, I can now connect to the 1072.1.1 address instead. And I want to accept the key. And now you can see that I am connected to the same box, but rather than going through the WAN, I am now going through the Wireguard instead. However, I don't recommend that you change the SSHD config to only listen on the Wireguard, because let's say if Wireguard goes down, you'll have no way to remote into the box. However, for myself, these are throwaway boxes anyway, so I don't really care what happens to them. I'll just spin up a new. So the first thing that I'm going to do is I'm going to install Unbound. So if I do apt install and then Unbound, yeah, there's already dependency, so we can just straight install from there. Great, now Unbound is installed. Now we need to do some configuration steps, because by default, Unbound does nothing out of the box. So what I will recommend to do is I'll leave a link down in the bio. Go to the Pi-hole's website and copy their configuration that they give you. It has all the best default configs out of the box. So following the Pi-hole steps, we'll change directory first into the etc Unbound, and then there's unbound.confd directory, and we'll then vim, we'll nano a pihole.conf file. Inside this pihole.conf file, I will be pasting the exact same details that are on the website. So like I say, I recommend that you go down there and you grab the configuration from there. However, before we move ahead, we need to change the configuration that Pi-hole has given us. Because by default, Unbound allows 192.168 addresses. However, our interface is listening on 1072. So at the bottom, I've added this access-control colon, and then I've done 1072 1.0/24, and then allow_snoop. So that will then grant us access on that interface. And then at the very top, I've then defined that I want Unbound to listen on the 1072.1.1 interface, which is the wg0.conf. Once you've made those changes, if we do systemctl restart, and then we'll restart the Unbound service, you'll now see that it's restarted fine. And if we look at status, we can now see that Unbound is running and there's no errors. However, before moving forward, we should make sure that Unbound is allowing requests and is working perfectly fine. There's some examples on the Pi-hole documentation that you should use. So this is just one, for example. So you can run the dig command. We'll look at pihole.net. So that's pi-hole.net. And then we'll do the @ to give a custom DNS resolver. So we do 1072.1.1, and then we do port, which is 5335. That is the default port that we've given from the Pi-hole configuration. Running that should show you the Pi-hole answer. If you get an answer, that is great, and that is all working perfectly fine from the server's perspective. Now we're going to be moving over to the Pi-hole installation. This installation, I'm just going to be taking the curl script that's already on the Pi-hole GitHub page. So I'm just going to be pasting it in here. It's just a curl to install.pi-hole.net and then pipe it into bash. So I'm just going to run that. So there is no SE Linux. So if you are running SE Linux, the first thing that I tried to do was run it on Rocky Linux. You need to turn off SE Linux altogether because there is no custom things like that. So installer will transform your device into a network-wide blocker. Okay. And then it needs a static IP address. We already know it has a static IP address because I'm running it in the cloud. So we can continue. And then this is where it will say, do you want to choose an interface? I do. I want to change it over to WG0 because that's where I want my mine to run. And then from there, we'll change over to the select. Now it's asking us which upstream DNS providers we wanted. We just installed Unbound, so we can change as to Unbound. So we'll do custom, and then inside here we'll do 10.72.1.1, and then we'll do pound or hashtag 5335, and that will then set up that upstream Unbound server for us. And then it will ask you to confirm, saying, are you sure this is the 1072.1.1 5335 server that you wanted? Yes, it is. And then, yep, in Pi-hole, we do the Stephen Black's Unified Host list. That's fine. Do you want to install the web interface? Yes, we do. It's asking, do you want like HTTPD? Yes, we do, because we don't want to go through the trouble of setting up a web server ourselves. Would you enable query logging? For me, I say no. However, if you get any issues, you may need to turn it on just to see what the issues are, but I'm going to say no. I'm going to change it to anonymous mode because I don't want my Pi-hole or Unbound to be logging anything. That's great. So we'll do that now. So this is where it will tell you the interface and where and what your password is. At the moment, I'm not going to take any notice of this password. I'm going to change it afterwards, after I've made the next change. So now, since we've got Pi-hole installed, it's running, and it already has that up and running. The first thing I'm going to do is I'm going to change which interface the admin interface is running on, because if I run SSLNTP, we'll see that port 80 is open, and I don't want to be exposing my admin interface to the internet. I just want it to be accessible for me once I connect through WireGuard. So we'll nano into etc light HTTPD by default, and then we'll go into the light http.conf, and inside here we're gonna add a entry for server.bind, and then we're gonna enter 1072.1.1. Make sure you wrap it in quotes. That's what I've done and it works. Hey, I'm just going to interject this bit just in the section here. So by default, light HTTP listens on IPv6 address. However, I don't want it to. So if you come back into the light HTTP conf, and you'll find this section here saying by default port for IPv6 fallbacks to IPv4 port, which is fine. You can just comment this out. And then after that, we'll then do systemctl restart light HTTPD. And now if we look at the SSLNTP, we now see that the admin interface is now listening on our wg0.conf. So I didn't take any note of that password, so I need to run the pihole-a-p command. This will allow me to set a new password. So that is a new password set. The reason that I do it afterwards is because, let's say if somebody tries to attack my web interface when it's exposed for a couple of seconds while I'm changing the light http.conf, there's a random password that I don't even know. Okay, now we're going to head into the admin interface for Pi-hole, because now I want Pi-hole to only listen on WG0's interface only. So you're going to type in the password that you just done. If you don't know how to get here, you would just do 1072.1.1 and then /admin into the web page. Make sure that it's HTTP : before doing it, because sometimes some of the browsers update you to S and you won't be able to see the page. Type in your password that you've got. So now we're into the admin interface. What we're going to do here is head into settings, head into DNS, and then we're going to set it to bind only to the interface WG0. So I don't want it to be pointing to the internet, even though the port may be filtered and it might drop the connection. If somebody does an Nmap scan or anything like that, they will still be able to see that port 53 is open to the internet. Once that is done, we're going to hit save. To the server, if I do SSLNTP again, we can now see that we now have a local DNS bind to 127. That's only for loopback queries. And then we also have 1072.1.1, which is the Wireguard interface. Right, that is the server setup done. So we've got the Pi-hole, we've got Unbound, and then we also have Wireguard set up and running. Now we need to tell the Wireguard that's running on my local machine, the client, to use that as its DNS server. So we'll head over to my terminal. We'll nano the burn.conf again. And then in the interface at the very top, we'll do DNS in all caps equals, and then we'll do the 1072.1.1. Because Pi-hole is now listening on that bind address, we can now point it to there. So we'll save that. And then we'll quickly do wg quick down on the burn, which will bring it down. And then we'll run the up command, which will then reconnect me to the Wireguard interface. We can make sure that this is working. So if we open a private browser and we head over to something like bbc.co.uk, heavily renowned for a lot of ads, there's nothing on here. If we head over to theverge.com, heavily known for a lot of ads, you'll see over here that there is no top banner, there's no ads anymore, because now we're using that DNS server as our server. We can double check that that is working if we go to 1072.1.1 and then /admin. You can now see that we're getting queries, and we're getting queries that are blocked. But now there's an extra step that I want to do, and that is setting up a Tor rotating proxy. Just so if there's any point that I really want to stay anonymous, I can then connect to that SOCKS proxy, and then we can move forward from there. So I'm going to go onto GitHub, and I'm going to search for multi-tour Docker. And then the first one that comes up, Docker multi-tour. This is the GitHub project that I use. So from here, we're just going to do copy the link up here, move over to our server. So I'm going to change over to the op directory. From here, I'm going to git clone that link. So that's evade security Docker multi-tour. Great, that's done. And before moving ahead, I'm going to need a containerization. I normally use Docker, but I want this to be a lightweight as much VM. So I'm just going to do apt install podman. It's daemonless and it doesn't run it as root. So if there's any chance of it getting rooted or anything like that, it's very minimum because now we're running it podman instead. Great. Once we now move into the Docker multi-tour directory, there's one change that I need to make before I build, and that is the startup.sh file that comes with it. I don't like the proxy into HA proxy because that's more of a HTTP stuff. So all you got to do is remove this and change the proxy to SOCKS. So what will happen with this configuration is it puts HA proxy in front and then all the Tor instances behind, and then you basically switch through each request through to the different SOCKS or the different Tor instances, should I say. So we'll save that. And now we'll run podman build on the current directory by putting the dot. We'll then tag this with multi, just a small name that I like to call it. And then we'll build it. So I'll see after it's built. Great, now podman is built, the image that we need to run. So now we're going to run podman by creating the pod. So we're going to run podman run, and I like to type out straight away the image. So it's localhost/multi, localhost to slash, because obviously we built it locally and that's what it prefixes the images as on podman. And then we're going to give it a port to run. And I'm going to wrap this in quotes because it's going to be a interface, a port, and then a port inside the container. So as you can guess, I am going to bind it to 1072.1.1, and I'm going to bind it to 9050. So 9050 by default is Tor. The reason that I picked this is some tools, when you use the -- Tor, they just automatically go to 9050. And then I'm going to paste in the port that HA proxy uses inside the container, which is 16379. We are then going to prefix the run command with -d because I want to run it in detached. I don't want to see the output. And then after, if the container dies or anything like that, I'll just do --rm just to remove it. It's just easier to do it like that because let's say if I come back onto the box and the container is dead, I can just rerun it and bring it back up. And it was just easier to do it that way. We can confirm that this is running if we do podman ps. We can see that it's up and it hasn't crashed. We can then do podman's logs on the container ID. Hey everyone. So this is going to be like a weird jump cut because I've been trying to debug this for like an hour. So we're going to move on to the, what you probably just saw was me building the multi-tour setup and moving it through podman. However, when I first ran the container, so what you first need to do is run it with these arguments. So podman run detached into the RM, and then tell the port to go to 1072.1.1.9050 and then 16379 inside the container, and then localhost/multi. Once you run this, if you get what I was getting, so I will show you. So if I do the podman ps, we get the container ID. If I now do podman logs on that container ID, you'll either see that you created 5 in green or they're not created in red. So if you don't see them created in red, all 5 of them, then it's having some weird networking issue. So what I had to do was I had to do podman exec IT for interactive, paste in the container ID, and then go into bash. And then what I did is I did apk add curl. So it added curl, and then all I did was curl, like let's say google.com as an example. Obviously you can see that I got the connection, and then from there I just did /, and then I reran the setup.sh file or startup.sh file that was inside the container already, and then it worked straight away. So I was like, okay, I'll come out and I'll rerun that command, and just to obviously show you as a live action what would happen and stuff like that. However, it now works. I have no idea, it just works. Okay, so let's get this video back on track because I've been debugging it for like an hour. So if we now check the SSLNTP, you can now see that we have 9050 focusing its efforts on the 1072.11 address. So the only thing that we've got exposed to the internet is the SSH port, which for me, the SSH port only accepts keys anyways. So there is hardly any risk to that unless somebody steals my keys. Okay, so I will show you how to use that SOX proxy. So if I go over to my browser, and I have got a tool on my Firefox called Foxy Proxy. So this is just an easy way to turn on and off proxies. You can do it manually inside your browser settings. However, if you use Firefox like me, I recommend you to install this extension. So I'll head over into options, and then on here you can see that I've got in my option burn, it's got 1072.11. From here, I'll just click edit. And then from the edit settings, you can see here now where we got the proxy IP address 1072.11, and then the port, as you can see, is 9050. There is no authentication on it, so you make that. Make sure that the proxy type is SOX5 because that's the one that I like the best. If you look into multi-tour a little bit more, there is a lot of settings that you can do. I just like the proxy SOX the best for myself, because it works well with tools. However, if you want to change or modify that startup script, you can do that also. Now let's see if my proxy is working as it should be. So if I just go over to .go and I just type in what is my IP, or what is my I apparently, but if I click on what is my IP address, it will take me over to this shady website. And now you can see that my IP address is 185.56.83.83. However, if I move back over to my address here, if I do IP ADDR, you can actually see my server is 178.62.101.245. So that is not my server. And then if I do a refresh on that, you now see that my IP address has now moved on to the next IP in the list. This is what I was talking about, the rotational Tor proxies. It will just keep rotating through them. So when you're like browsing a website, each request you do can be a different IP address. It just does the round robin effect. And then if we refresh one more time, see which IP address we get here. However, there's one thing to note here. This isn't foolproof. This is very easy to detect depending on what type of systems of the business. I just want to premise this with everything you learned here is great for privacy, great for red teaming. However, any assets that you try to attack, or let's say use this information to attack, it's all on you. This is a disclaimer. You should always have permission before you attack somebody's infrastructure, or even your own infrastructure. You should only do that. It's just a disclaimer. I don't want anyone to come back to me and say somebody with your video has managed to do this. But as you can see, the IP address keeps rotating through, so it's just completely just anonymizes you in that way. However, let's just hop over to my website. So if I go to blog.lawrencejones.dev, that is my website. However, accessing my website, you can see that I've got Cloudflare in front. So Cloudflare has some sort of detection. It will basically get through your browser, make sure that you're not a bot, like user agent, stuff like that. I don't know what Cloudflare does on their side. They're not really obviously transparent with that. However, if you can see here, I've now hit my own firewall or my own prevention measures, which is CrowdSec. So I have CrowdSec installed on my machine. So I'm going to be fully transparent. I do work for CrowdSec, and it's not like I'm trying to shoehorn it into the video or do anything like that. I'm just going to try and make you aware that there are obviously detection measures that are out there that can obviously foil this going through Tor as a relay. So CrowdSec has an upcoming feature called block lists, and in the block lists you can opt in for the Tor endpoint block list. Using that on your service obviously prevents these types of attacks, because if I try and refresh the screen and resend it, what will happen is it will go through the next IP address, but the next IP address is obviously Tor, and that will also be banned. And then if I rotate again and do that, then it's again. However, if I now turn off my proxy and then refresh the screen, you can now see, because I'm coming from my VPS in the cloud, I don't have a bad reputation, or I'm not coming from the Tor network, so I can get through that way. Obviously, the server on my end can only see the DigitalOcean server. So that's one way that you can get around it. You can still browse the internet and do stuff like that. However, there's some people that go further beyond, and they will also detect if you're hosting, if you're coming from a VPS like ASN, and they can also block you from. So I really hope you enjoyed this video. So this was just walking through how to set up Wireguard through the server side as well as the client side. As you can see, it's only like a small bit of configuration. There isn't too technical implementation. This is obviously just one client. You can just re-step over the client thing if you really wanted to add more clients. And then we moved over to installing Pi-hole. And then from Pi-hole, we installed Unbound, which is like a recursive DNS. And then we basically configured all of them to only listen on the Wireguard port. So because Wireguard is UDP and stateless, if anyone was scanning the internet to try and see if they can find an open port, Wireguard doesn't respond by default. It will only respond when there is a active connection that can actually decrypt. So the way that you can see the Wireguard port, if you do SS and then LNUP, so that's listen with UDP and port, and then from there you can then see that we've got it exposed on 51820. And then finally we went through the rotating proxies, which wasted 1 hour of my life trying to figure out why it wasn't working, but then it decided to work for some odd reason. So you can basically restart that proxy and you will just gain new Tor IP addresses that it just shuffles through. So like I said, if you, let's say, go to a website that you don't really want to be tracked on, or you are an engagement and you just want to obfuscate your IP address, turn on the SOX proxy, go to the website, do what you need to do, and then obviously turn it off and redo it. Once your IP address has been found out, I normally recommend you to maybe do this on a weekly, just burn the server. At some point, I do want to automate all of this deployment, just because it would be quite easy for this to be automated, because there's only a few manual changes that you need to do. All the rest of it can be quite done by the system on the NIT. But I'm hoping that you enjoyed this and you learned something about this. I've been playing with this all morning and now through to the nighttime because it's nighttime here now. But I'm really hoping that you enjoyed it, and I'll see you in the next one.